I recently performed these visuals live at Boothstock Festival in Rotterdam, and because many of you seem to like this, today's tutorial will be this exact visual. As you can see, this network has a lot of options and is really fun to play around with. In this tutorial, we're going to take a deep dive into this network. I'm going to try to keep it engaging and easy to watch, but I do need a bit more dedication from your attention span, as this will be a longer and bit more complicated video than usual. The heart of this visual lies in a technique called instancing. I will start with a short explanation of how instancing works. You do not need to recreate this part yourself. So imagine I take a box and then I connect this to a geometry. Now I can make this box a bit smaller. And we can look at this box. I'm gonna center it at 0. And now we can give this box a new position by using instancing. Of course we can move it around using these parameters, but we can only do this for one box. The cool thing about instancing is that it allows us to create more boxes in the same geometry. Okay, the first thing we can do is grab a constant. This is just 1 by 1 pixel, so literally 1 pixel. If we call this translate and we drop this on the instance tab of the geometry, we drag this translate up and RGB. We lost our box because it went up here. Now, what we're doing here is we're connecting the red channel from our image to X, the green channel to Y, and the blue channel to Z. So right here we can change our pixel, our 1 pixel. And you'll see that with our current setup, we can change the location of this box. So this is our X axis, this is our Y axis, and this is our Z axis. We can delete this constant, and now instead of a constant, I'm gonna grab a noise, and I'm gonna give this a 10 by 1 resolution. Now, if I click viewer active and right click display pixel values, I can see we have 10 pixels because 10 by 1. Now, when we instance this, each pixel will represent a new instance of our box. So now we have 10 boxes, and they're now aligned in this line. That's because our values all go from 0 to 1, and in each pixel, red, green, and blue is the same. Now, if we turn this noise to monochrome off, we will get our normal noise, our colored noise, and you can see we now have these at semi-random positions. And if I make this way smaller, let's say 0, 1, and I increase the resolution, we will get more and more points. So if we make it 10 by 10, we now have 100 points in 3D, 100 really small boxes. And if we increase this further, we get this point cloud. And you've probably seen a lot of point clouds already. If not, this is how you make them, but instead of box, you use just a particle. And we can increase this further and further, and we can do all kinds of cool stuff with this. If we increase the period of the noise, so the noise becomes more smooth, the shape also becomes smoother. So we get this funky 3D shape, which is really cool. And we can obviously animate our noise, and if we do this, our 3D shape will be animated. Currently, we see that at some time it... no, I need to increase the resolution. Sometimes it bumps into the edges, so it doesn't go farther than this box of 1 by 1 by 1. And that's because our pixel format only allows our pixels to be between 0 and 1, which is only logical if you're using this to represent literal pixels, because your screen can't go brighter than 1 and can't go dimmer than 0, because that's just not possible. But for this instance, we want a 32-bit float, which allows us to go way bigger and way smaller and negative. And now our shape is somewhat free, and we can also insert a math and change the size of our shape. So now it's only in this box of 0 to 1 for all axes, and if we change this to be from 0 to 1 to -1 to 1, now it goes, you can see I stretch it and it becomes bigger, and it's centered around 0. What we're doing in our visual is using instancing to display all our boxes and use some cool tricks to only move them on this axis and give them different shapes, because we can also give each box a unique shape corresponding with another image. So if we also drag this onto the scale up and do RGB, we can see that the boxes, let me pause it, have different shapes, and we can control this, and this is really useful. And the powerful thing is that all the position management is done in TOPS, which is really efficient because it's running on the GPU. Right, having cleared that up, we can start building our visual. Again, we're going to start with a noise top. And we're going to give this a resolution of 35 by 35 and give it the pixel format 32-bit float. Turn monochrome off and give it a period of 2. And that's the most important for now. Then press Alt and N to get it null, or just search for a null if that doesn't work. And press Alt N again and select this null and right click and press collapse selected. And we're gonna call this live component random speed. And what this does is it gives like a direction to our particles, to our position, because currently in the previous example, the noise flows smoothly, but it doesn't start somewhere and end at another point. It just has a random position. And what we can do is we can multiply this image. Let's say if we were to composite and give this the same resolution, so 35 by 35, and we multiply these two images with each other. If this is 1, so then the image will just be the same, because we will take the input image, and let's say top left is 0.53 for the red channel. If we multiply it by 1, 0.53 times 1 will just be 0.50. That's strange. Why is that? Oh wait, this needs to be 32-bit float as well. Then it will be 0.53. If we set the red channel of this one to 0.5, it will be going times 0.5, so it will be half. And what we can do is we can give the pixels a trail, like a direction, by multiplying them by something that flows up from 0 to 1. So if we gradually increase this from 0 to 1, the pixels will follow a trail towards their final position, and that way we're going to make them move in a straight line. Now the first time I saw this component being made was in a supermarket salad video. I love his videos, really check it out. And I think credits were given to Paqueta 12, like the TouchDesigner OG tutorial maker. You should also check that channel out if you don't know it. I'm going to recreate it, and I've altered it a bit to make it work for my case, but the roots of this network lie there, just to give credit. We're going to start by dragging a noise from this in and setting the output to be just noise. Then connect a limit top to this and change the minimum to clamp and set it to 0.01. And now we're gonna add a GLSL top. Now I know this involves some code, but don't be afraid. You can just copy it, and I will still explain what's going on, and it won't be really hard shader code. It will just be some simple lines. First we need to grab a constant chop, and for this one we're going to do rate and type me.rate, and then I think live should be yeah, we're going to go out of this network by pressing U or zooming out and customize this component and give it a custom page. And now we're going to give it a live parameter, which should go from anywhere between, let's say, 3 and 30. No, 1 and 30, and give it a default of 5. Okay. And then we can drag this and press I to go back into the network and drop it onto the this box. Or you can just type in this parent parentheses .par.live. Okay, now we can use a math to multiply this. So combine channels, multiply, then insert another constant, set it to 1, and another math, connect this here, and set the combined chops to divide, and then annul. Now go back to the GLSL and go to vectors and type in max, and now click this viewer active and drag it onto the first value of max. I will explain in a bit what we're doing here. No, I'm just gonna do it right now. We're going to make some kind of feedback loop that gradually increases for each pixel, but it's gonna increase at a random rate for each pixel. So what we're going to do with this max and with this GLSL top is, for every frame our feedback loop will run, we're going to determine how much it will increase. So currently our max is set to this value, which it can increase per frame at a maximum, but we're going to differentiate like the values between 0 and max, and this will make a lot of sense in a bit, I hope, if I do it correct. And we need this to give our blocks a random speed. So for this we're going to into the GLSL pixel, and what a basic GLSL script does is it runs for every pixel that the GLSL has. It runs this script, and for every pixel we only have the some inputs. We have the coordinates of the pixel, so we can make use of that, but we cannot reference other pixels. Yeah, it's a bit complicated, but first thing we need to do is declare our uniform, which we just call max. Like this is a uniform, and now we can access this value in GLSL. What we're going to do is we're going to, for each pixel, we're going to check what our input is. So we have an input, and for, let's say, the first pixel, we're currently running in the first pixel, then our input will be this, and I really want to know what that is. Luckily, TouchDesigner already gives us this line of code, so delete the backslashes, and we're going to call this input color. Make sure this is you leave this like this, but this index is for if you connect more tops. You can also access the second one, but we only need the first one right now. Then let's see, we're going to give this some space and type in float and call it red, and then type in ABS, open a parentheses, max times input color dot r, and close it with a semicolon. And what we're doing is we're storing the input color of the current pixel in this variable, and now we can access all of the input pixels values, so R, G, B, and A. And now by typing in input color.r, we get this value. So for this pixel, it will be 0.82. And now we're multiplying this by max. So now we get max times 0.82. So that will result in a value between 0 and max. We're storing this in a red channel. We can call this whatever we want. Doesn't really matter. And now what we're going to do is we can output a color. This is the output color that we're going to write to our image. If we change this to 0.5, it will become gray. You can also do as 1 and 0 and 1. Now we have some kind of green. We're going to store red in all channels. This is a bit confusing, maybe, but we just want for each we just want an increment of the same amount for each pixel. This is but it needs to be random. We could, if we wanted it to be like in the original a tool by Paqueta and Supermarket, we used constant with this value on all 3 channels. So then each pixel increases gradually on all 3 channels, but I want it to be random, and that's why we needed to do this. We can close this down. This should be working now, and we can continue by connecting this to an add. And then right here at the bottom, we're going to do a constant. And I believe we only need to set this to 0 and set resolution only. And yeah, that's that. Then we're going to insert a matte here. Grab a noise from this one and set it to random. Yeah, that's great. Then connect a feedback and a threshold. Thresholds. Set this threshold to 1. Yeah. And then we can connect the feedback to the second input of the matte and the threshold to the last input of the matte. And we can also, let's see, drag this over. And we can drag this also over and connect the matte to the second input of the add. And now drag the add onto the feedback. Alright, now we have this component working. We have pixels increasing at a random rate, which is what we want. Now we can exit this network by pressing U. And we can insert a math here and set the range from -4 to 4. Lovely. And call this red x-axis. We're going to control the x-axis of our blocks with this image. And we're going to connect this to a reorder. And this will be our Alt-N. This will be our translate. Okay, now we're getting close to actually seeing something in 3D. So hang in there. First we need, let's see, another noise. Because we're only going to control the red or x-axis with this network, but we're going to do something way simpler, way more simple for the green and blue axis. So grab this noise, set the resolution to 35 by 35, turn monochrome to off, and let's see, 32-bit float. Then connect a math and set the range to -1 to 1. And now feed this into the reorder. And for the reorder, we're going to be input 1 will be red. Yeah, okay, so the reorder chooses which inputs it uses for what output. So for our red output channel, we're using input 1. For our green output channel, we will be using input 2. And we won't be outputting any blue. So this will be our output for now. We can now grab a rectangle. Lovely. And we're going to connect this to a geometry. Turn instancing on, drag the translate on here, and connect R and G, because we're not doing anything with the Z-axis. Now we have some blocks moving, but they're way too big. This is already starting to look like what we're aiming for. We're gonna leave this at 1 and leave it be this ugly mess, because we're going to control the scaling with another chain of tops. So we just we can also make this smaller and control it in a different way, but I like to keep them at 1 so our calculations make sense. Again, we're going to start with the noise top. Set it to 35 by 35. Note that all the resolutions have to be the same, because if I increase one of the resolutions, it doesn't understand what it's doing. So make sure the resolutions are the same. We're going to set this to random, and we're going to set monochrome to off, and set the pixel format to 32-bit float. Press connect a math and set the math to 0 to, let's see, 0.06. And now Alt N and scale up. We can go to our geo and drag our scale in and RGB. I think we don't need any blue. No, that's right. And now we can control the size by increasing this value, so that will get bigger and smaller like this. This is already starting to look like our final product. We can put in a camera and set the translate a bit closer, like 2.2 or something. And then a render. And then, yeah, I had some crazy resolution of 6000 by 900 or something. Yeah, this was the resolution I used to showcase, but this is unnecessarily high for now. Let's do get the same aspects. Yeah, something like this. Lower. Now you can see they're still black. That's because we don't have any lighting going on. No, we're doing it with a constant. Grab a constant matte and drag it on here. And now we have some cool stuff. The thing we need to do to give it a feel of depth, because I'm not actually using any depth. This is just a flat image. It was more convenient to do it this way. We're going to control the color of these instances with another top chain, which is actually pretty easy. All we need to do is grab a, let's see, a noise. Again, everything is made with noise. And set this to random GPU and set this to 35. This does not need to be a 32-bit float, because now we're working with actual colors, and again the colors can't be bigger or bigger than 1 or smaller than 0, so this is fine. And we can just press Alt N and make this the color up. And now if we drag this on here and fill in our G and B, we get these different brightnesses. And this is really useful because later on we can use a lookup and ramp combination to color this, and because there is this feeling of depth because of the color change, we can give it a color and it will have this look, which is really neat. Next thing to do is to add the lines. Line. We're gonna need a line swap, and we're gonna set this point to about 15.5 and 2.4, and we're gonna add a geo and turn instancing on. And for these lines we're gonna reuse the translate up, just RG, also the scale up, RG, and then the color, can also use that one, RGB. And now we need to drag the constant material onto this, and now we also have some lines. It's pretty full now, but we can customize that by if we select all these these four noises and we drag the resolution down, make sure they stay the same. So if, let's say, we have 24 now it will be a bit less crowded. Now we've got the like the pre-part, like the rendering part in place. The next thing we're going to do is to make a post effect chain. So we're going to start with some feedback trail edge kind of thing. So we're going to take an edge of this visual and we're going to create, let's press Alt N twice and select this one, right click next to it and collapse selected, feedback loop. If you already have a feedback loop component, you can use that and just skip through a bit. We're going to build a feedback in here, feedback, transform a level, and insert a composite here. Connect this up, set this to add, drag this onto the feedback, and let's see, set the scale to 1.001 and the brightness to 0.97. And I think, yeah, then we're gonna add a level here and set the contrast to 1.17. Lovely. Now we have this trill thing. We're going to use this with a displace. Going to give the option to displace our image with this feedback. Set the source midpoint to 0, and we can set this also to 0, and if you increase this you get this displaced look. So I'm gonna set this to off, but this is an option now, and you can put this under fader or whatever you want. You can just use this. Next thing I like to do is connect an add here, and then connect a level after this trill. And now and we need to take this out, so delete this lookup and ramp combination, or do Control or Command X to cut it out. Place it here at the end and connect. Whoops, this is not. This is how I want it. This should be all the way at the end, otherwise we have only parts colored. And now with this level we can control how much we add to it, so we can add a trill, which I quite like. So there's your second tweakable thing. I'm gonna leave this at 0. And then we have our coloring, and you can do whatever you want with this. So we need we need some bloom, and this is lovely because it's yeah, it's super cool. It's a bit heavy, but so if your computer is not handling this well, I consider not using Bloom because it's quite a heavy tool, but it's really pretty. So if you can, just use it. So you're currently looking at the entire network. This network can produce everything if you tweak the right parameters. I already showed you that you can increase this level and add a trill, and you can do all sort of things. I've actually made this into a complete component where I can tweak the amount of particles, and I can tweak the size, and I can make them go faster and displace it, and make the lines bigger, and add a trill, make the bloom go bigger, and also change the resolution. And one more thing I built is I've got these buttons where you can randomly reset the intensity. So if we make them go super slow, you can see if I press this, the intensity changes. And you can make some flashing effect with this if you connect this to a beat or something. And you can also change the size. So this worked really well. I use this a lot, and you can make this go on a song, and they go faster. You see it a little less, but it's still cool if you flash it pretty fast. So this I will continue this tutorial and make this entire component on my Patreon. It means a lot that you followed this tutorial until here, and you can, in principle, you can figure out everything out yourself. But if you want to dive even deeper and make this network, and also make the possibility of changing the direction and adding all these features, please check out my Patreon. It means the world to me if you do. And yeah, see you there.